We're going to be talking about the electron configuration of the main group elements. The electron configuration is the arrangement of electrons in an atom's orbitals. And this arrangement is based on a energy-efficient filling up order. This diagram is the Aufbau principle, and this can help us remember this filling up order. So you want to go diagonal, and the filling up order is you're going to fill up the 1s first, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s, and so on and so on. You can use this principle to help you remember this order, or you can go ahead and remember the order straight like this. Now, another thing we want to remember is that the orbital s can hold 2 electrons maximum. It can hold less than 2, but maximum 2 electrons. The p orbitals can hold the 6 electrons. D orbitals can hold a maximum of 10 electrons, and F orbitals can hold a maximum of 14 electrons. Let's take a look at an example. Let's go ahead and determine the electron configuration of magnesium. The first thing you want to do is find magnesium on the periodic table. This will tell us how many electrons we need to arrange in a certain energy-efficient order. Now, the atomic number for magnesium is 12. So, for a neutral element, the number of protons will tell us the number of electrons. So if magnesium has 12 protons, then it will also have 12 electrons. So we have to arrange 12 electrons in a energy efficient order. This principle that I have here is going to allow us to determine that order. The first thing we want to do is fill up the 1s, and we know that s can hold 2 electrons. Then we want to fill up the 2s. S can hold 2 electrons. Then we're going to fill up the p. We can fill up 6 electrons. And then we're going to do 3s, 2. So I can go ahead and add my superscripts. 2 plus 2 is 4, plus 6 is 10, plus 2 is 12. That's all of my 12 electrons. So the electron configuration for magnesium is 1s2, 2s2, 2p6, 3s2. Another thing the electron configuration can tell us is the number of valence electrons. My valence electrons are going to be the electrons in the outermost shell. Now, the outermost shell means the energy level that is the highest. So I have energy level 1, I have energy level 2, I have energy level 3. The highest level is 3, and inside of level 3, there are 2 electrons. So this means that there are 2 valence electrons. So magnesium has 2 valence electrons, and I can double check that by looking at the periodic table. Magnesium is in group 2. So the group number of the main group elements will always be the number of valence electrons of that element. So all of the elements in group 2 will have 2 valence electrons. All of the elements in group 1 will have 1 valence electron. And group 3 will have 3 valence electrons, group 4 will have 4 valence electrons, group 5 will have 5 valence electrons, group 6 will have 6 valence electrons, group 7 will have 7 valence electrons, and group 8 will have 8 valence electrons. So we have the electron configuration, we have the valence electrons. Let's talk about cations and anions. Let's talk about what if magnesium were to behave as an ion, something that's charged. Well, if magnesium were to behave as a ion, it would behave as a 2+ cation. Now, what would be the electron configuration of magnesium 2+? Well, a neutral magnesium has 12 electrons. A cation is something that gives up its electrons. So 2 plus means it wants to give up 2 electrons. So if I start off with 12 and I give up 2 electrons, that means I only have 10 electrons. So I want to arrange the magnesium 2 plus electrons in the energy efficient order. 1s2, 2s2, 2p6. So 2 plus 2 is 4 plus 6 is 10. Now the valence electrons for my cation is going to be the highest level shell, which is 2. There are 2 plus 6, which is 8 valence electrons. The ions of the main group elements will always have 8 valence electrons because that obeys the octet rule. Another thing we can talk about is something called the abbreviated electron configuration. The abbreviated form allows us not to write the long configurations. We can take something of a shortcut. So let's look at magnesium. Magnesium, the neutral magnesium, depends on the noble gas that comes before it. So here's magnesium. The previous noble gas is going to be neon. So neon has 10 electrons. So that means it's accounting for these 10 electrons. So magnesium's abbreviated notation, you would put neon in brackets. Neon is the 10 electrons, and what's left over is the 3s2. So neon accounts for 10 electrons plus these 2, that means 12 electrons. The noble gas that we use is always going to be the previous noble gas of that element. Let's take a look at another example. Let's determine the electron configuration for bromine. We have to find bromine on the periodic table. Bromine is right there, and a neutral bromine has 35 protons, so a neutral bromine would have 35 electrons. You want to arrange those 35 electrons in the most energy efficient order. I'm going to use the Aufbau principle to help me with that order. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4b5. If I add up all of the superscripts, I'm going to get 35. Something you want to pay attention to is that this filling up order doesn't necessarily go in some chronological order. There's always going to be a hiccup between the p orbital and the d orbital. So 3p6, then I would fill up the 4s2, then come back and fill up the 3d10. Naturally, we want to try to fill up the 3s, 3p, 3d, and then start with the 4s, but that's not how this filling up order works. So once I have all of my 35 electrons, I can go ahead and try to determine the valence electrons for bromine. The valence electrons are the electrons in the outermost shell. So I'm going to look for the largest energy level, which is 4 in this example. I'm going to underline all my 4s, and then I'm going to add up all of the electrons that are in level 4. So 2 plus 5, this is 7 valence electrons. And let's take a look at the periodic table. Where is bromine on the periodic table? It is in group 7. And that matches up because group 7 elements will always have 7 valence electrons. Now, if bromine were to behave as an ion, what would it behave as? It would behave as an anion. And what do anions do? they gain electrons. So a neutral bromine has 35 electrons. Br minus would have 36 electrons. So I'm going to add one more electron. Let's talk about the valence electrons of Br minus. I'm going to underline all of my energy levels, my highest energy level, which is 4. I have 2 plus 6, I have 8 valence electrons in my ion, which correlates to the octet rule. Another thing we can talk about is the abbreviated electron configuration. We have to start off with the neutral element for the Br. And we look at Br, and the previous noble gas is going to be argon. So argon takes over 18 electrons. Here's 10, 18 is right here. So the abbreviated electron configuration would be argon in brackets, and then the rest of those electrons. So argon is 18, 20, 30, 35. Good luck and keep practicing.